All right, so in this question, I'm asking you a bit of a kind of bizarre scenario here. So I'm saying we're putting some dry ice into a bottle that's covered with a balloon. The opening's covered with a balloon. And we're dropping this into the ocean and making it sink. All right, so there's a lot of things going on here. All right, so in this scenario, I give you the temperature of the dry ice. So it's about minus 80 degrees Celsius. So the ocean off of Naples is a lot warmer than that, obviously. All right. So the question is asking about the sign of work, heat, and delta E. All right. So let's start off with work. All right. It's maybe the easiest one to start off with, in my opinion, because there's actually an equation for it. All right. So work. We're going to start off again. Work is going to be equal to negative P delta V. All right, so just like we said in the last problem, pressure is always going to be a positive number. All right, so we're really interested in what the sign on delta V is here. So, all right, delta V, all right, it's going to be equal to the final volume minus the initial volume. So, all right, in this case, the water pressure from the ocean is pushing the balloon into the bottle. That's what the question says. All right, so that means that our final volume is going to be smaller than our initial volume. All right, so we're going to start with a small number, subtract a big number from it. All right, so that'll cause you to get a negative number. If you're confused about that, again, just assign yourself some numbers, these volumes some numbers. So we're going to say, initially, we're starting off with the volume of 2. Because our volume is shrinking, we're going to end up with a final volume of 1. And so this basically, do 1 minus 2, it's negative 1. So that means our change in volume is going to be less than 0. All right. So basically now we have a negative sign here. Pressure is always positive, and delta V is negative. So we have a negative times a negative. All right. That means that work here is going to be positive in this case. So you could also think about this kind of anecdotally. So in this case, the ocean, it's doing work on the system. So it's pushing on the system, causing the system to shrink, right? So remember, our system is lazy. So a system does not want to do work, so it wants work done on it. So because work is being done on the system and it's getting smaller, that means that our work is going to be positive. All right. So for the second part, we're interested in the heat. All right. In this case, all right, so heat Q. All right, the thing you need to know is what's written here. So that heat flows from areas of positive temperature to areas of cold temperature. All right. So, all right, there's no nice equation for heat given in this chapter, so you just have to kind of think about this one. So, all right, our system is cold. All right, it has the dry ice, which is really, really cold. So there's heat flowing from the warmer water around it to the dry ice. All right, so our system is also selfish. All right, does it like to, that which means that it likes to gain heat. All right, so because of this, our sign for Q here is going to be positive. All right, because our system is taking in heat, it likes that. So our work is positive and our heat is positive. All right, to figure out delta E, all right, the thing you need to know, that equation is delta E is equal to Q plus W. All right, so if both Q and W are positive, that means delta E is going to be positive. If both Q and W are negative, then delta E is going to be negative. All right, if one is positive and the other is negative, we would actually need to know the numbers and not just the signs in order to figure out the sign of Q, or sign of delta E, sorry. So that's it. Thank you.